It wasn't long ago that people thought that Earth was the center of the universe. Another mistaken idea is that Earth was flat. Hi, and welcome back. In today's science episode, I will talk about our unique planet Earth.
Earth. Spherical shape. A round, three-dimensional object is called a sphere. Its surface is the same distance from its center at all points. Some common examples of spheres are basketballs and tennis balls. In the late 20th century, artificial satellites and space probes sent back pictures showing that Earth is spherical. Much earlier, Aristotle, a Greek astronomer and philosopher who lived around 350 BC, suspected that Earth was spherical. He observed that Earth cast a curved shadow on the moon during an eclipse. In addition to Aristotle, other individuals made observations that indicated Earth's spherical shape. Early sailors, for example, noticed that the tops of approaching ships appear first on the horizon and the rest appear gradually as if they were coming over the crest of a hill, as shown in Figure 1. Additional evidence. Sailors also noticed changes in how the night sky looked. As they sailed north or south, the North Star moved higher or lower in the sky. The best explanation was a spherical Earth. Today, most people know that Earth is spherical. They also know all objects are attracted by gravity to the center of a spherical Earth. Astronauts have clearly seen the spherical shape of Earth. However, it bulged slightly at the equator and is somewhat flattened at the poles, so it is not a perfect sphere. Rotation. Earth's axis is the imaginary vertical line around which Earth spins. This line cuts directly through the center of Earth, as shown in the illustration accompanying Table 1. The poles are located at the north and south ends of Earth's axis. The spinning of Earth on its axis, called rotation, causes day and night to occur. Magnetic field. Scientists hypothesize that the movement of material inside Earth's core along with Earth's rotation generates a magnetic field. This magnetic field is much like that of a bar magnet. Earth has a north and a south magnetic pole, just as a bar magnet has opposite magnetic poles at each end of each of its ends. When you sprinkle iron shavings over a bar magnet, the shavings align with the magnetic field of the magnet. As you can see in Figure 2, Earth's magnetic field is similar, almost as if Earth contained a giant bar magnet. Earth's magnetic field protects you from harmful solar radiation by trapping many charged particles from the sun. Magnetic axis. When you observe a compass needle pointing north, you are seeing evidence of Earth's magnetic field. Earth's magnetic axis, the line joining its north and south magnetic poles, does not align with its rotational axis. The magnetic axis is inclined at an angle of 11.5 degrees to the rotational axis. If you follow a compass needle, you would end up at the magnetic North Pole rather than the rotational North Pole. The location of the magnetic poles has been shown to change slowly over time. The magnetic poles move around the rotational geographic poles in an irregular way. This movement can be significant over decades. Many maps include information about the position of the magnetic North Pole at the time the map was made. Why would this information be important? What causes changing seasons? Flowers bloom as the days get warmer. The sun appears higher in the sky and daylight lasts longer. Spring seems like a fresh new beginning. What causes these wonderful changes? Orbiting the sun. You learned earlier that Earth's rotation causes day and night. Another important motion is revolution, which is Earth's yearly orbit around the Sun. Just as the Moon is Earth's satellite, Earth is a satellite of the Sun. If Earth's orbit were a circle with the Sun at the center, it would maintain a constant distance from the Sun. However, this is not the case. Earth's orbit is an ellipse, an elongated closed curve. The Sun is not at the center of the ellipse, but is a little toward one end. Because of this, the distance between Earth and the Sun changes during Earth's year-long orbit. Earth gets closest to the Sun about 147 million kilometers away around January 3rd. The farthest Earth gets from the Sun is about 152 million kilometers away. This happens around July 4th each year. Does this elliptical orbit cause seasonal temperatures on Earth? If it did, you would expect the warmest days to be in January. You know this isn't the case in the Northern Hemisphere. Something else might cause this change. Even though Earth is closest to the Sun in January, the change in distance is small. Earth is exposed to almost the same amount of sun all year, but the amount of solar energy any one place on Earth receives varies greatly during the year. Next, you will learn why. A tilted axis. Earth's axis is tilted 23.5 degrees from a line drawn perpendicular to the plane of its orbit. It is this tilt that causes seasons. The number of daylight hours is greater for the hemisphere or half of Earth that is tilted toward the Sun. Think of how early it gets dark in the winter compared to the summer. As shown in Figure 3, the hemisphere that is tilted toward the Sun receives more hours of sunlight each day than the hemisphere that is tilted away from the Sun. The longer period of sunlight is one reason summer is warmer than winter, but it is not the only reason. Radiation from the Sun. Earth's tilt also causes the Sun's radiation to strike the hemispheres at different angles. Sunlight strikes the hemisphere tilt towards the Sun at a higher angle, that is, closer to 90 degrees, than the hemisphere tilted away. Thus, it receives more total solar radiation than the hemisphere tilted away from the Sun, where sunlight strikes at a lower angle. Summer occurs in the hemisphere tilted toward the Sun, when its radiation strikes Earth at a higher angle and for longer periods of time. The hemisphere receiving less radiation experiences winter. Solstice. The solstice is the day when the Sun reaches its greatest distance north or south of the equator. In the Northern Hemisphere, the summer solstice occurs on June 21 or 22, and the winter solstice occurs on December 21 or 22. Both solstices are illustrated in Figure 4. In the Southern Hemisphere, the winter solstice is in June and the summer solstice is in December. Summer solstice is about the longest period of daylight of the year. After this, the number of daylight hours become less and less until the winter solstice, about the shortest period of daylight of the year. Then the hours of daylight start to increase again. An equinox occurs when the Sun is directly above Earth's equator. Because of the tilt of Earth's axis, the Sun's position relative to the equator changes constantly. Most of the time, the Sun is either north or south of the equator, but 2 times each year it's directly over it, resulting in the spring and fall equinox. As you can see in Figure 4, an equinox, the Sun strikes the equator at the highest possible angle, 90 degrees. During an equinox, the number of daylight hours and nighttime hours is nearly equal all over the world. Also, at this time, neither the Northern Hemisphere nor the Southern Hemisphere is tilted toward the Sun. In the Northern Hemisphere, the Sun reaches the spring equinox on March 20 or 21, and the fall equinox occurs on September 22 or 23. In the Southern Hemisphere, the equinoxes are reserved. Spring occurs in September and fall occurs in March. Earth Data Review. As you have learned, Earth is a sphere that rotates on a tilted axis. This rotation causes day and night. Earth's tilted axis and its revolution around the sun causes seasons. One Earth revolution takes 1 year. In the next section, you will read how the moon rotates on its axis and revolves around Earth.
I hope you found this video interesting. Thanks for watching and until the next one. Bye!